Today we're going to be talking about our introduction to factoring, and we're going to start first with our vocab. Greatest common factor is simply the largest factor that two or more terms have in common. So we are going to compare two terms to find the GCF, and today we're going to be factoring strictly by GCF, and we'll build upon this over the next few days. All right, so first thing I'm going to do is I'm going to take the two numbers it wants me to find the GCF for, and I'm going to put 1 in column 1 and 1 in column 2. Now remember, we talked about you can find factors of 2 by using the y equals on your calculator. So remember, I can take this 2 and I can do y equals 2 divided by x to find all of the factors if you get stuck. There's only two factors of 2, that is 1 and 2. For factors of 8, I have 1 times 8, and I have 2 times 4. There are no other factors of 8. What I'm going to do from here is I'm going to circle common factors, so they both have a 1 in common, and they both have a 2 in common. My GCF is going to be the largest of those factors. So in this case, my GCF would be 2. All right, let's try two more numbers. We have 20 and 50. First thing I'm going to do is list all my factors of 20. Again, you can use your calculator if you get stuck. I have 1 times 20. I then have 2, and 2 times 10 gives me 20. And I have 4 times 5. That is all the factors I have of 20. Now let's look at 50. I have 1 times 50. I have 2 times 25. I have 5 times 10. That's the only factors I have of 50. So then I'm going to circle the common factors. They both share a 1 in common. They both share a 2 in common. They both share a 5 in common. And they both share a 10 in common. So the GCF, remember, is the largest of those that I circled. So that would be 10. All right, let's try another one. This time I'm going to have 3 numbers. So I have 6, 18, and 21. Factors of 6 would be 1 times 6 and 2 times 3. Factors of 18, I could do 1 times 18. I could do 2 times 9. And I can do 3 times 6. Remember, once I get down to these two numbers, if the values in between them are not factors, I know I've finished. 4 and 5 are not factors of 18, so I can stop there. All right, now factors of 21. I have 1 times 21, and I have 3 times 7. 4, 5, and 6 are not factors, so I have finished. Okay, I'm looking for a factor that's in all 3. So that is a 1. They don't all have a 2. They all have a 3. They do not all have a 6, a 7, a 9, an 18, or a 21. So those are the only 2 factors of all 3 numbers, and we want the largest one, which is 3. All right, now let's look at GCF of variables. So if I have an x and an x squared, what I'm basically going to do with these is I'm going to expand it out. So an x is just a single x, but x squared means I'm doing x times x. I'm going to circle the number that they share in common. They share 1 in common, therefore my GCF is a single x. On number 5, X cubed is the same thing as x times x times x. X to the fifth is x times x times x times x times x. You can see that they both have 3 x's in common. Therefore, my GCF is actually going to be x cubed. All right, let's do this last one. We have x squared, x to the fourth, and x to the eighth. X squared, we have 2 x's. X to the 4, I have 4 x's. And x to the eighth, I have 8 x's. The most that they all have in common are 2. So my GCF of all 3 is x squared. Now, if you look at those 3 examples, you'll notice that my GCF is the same thing as the smaller exponent. So x and x cubed and x cubed, x squared, and x squared. It's always the term with the smallest exponent. All right, so what exactly is factoring? Factoring is going to be the process of undoing the distributive property. So what process are we using when we distribute? That is multiplication. So if I want to undo that, I'm going to have to use division. So let's take a look at this example. If I was to simplify the expression using my distributive property, I would do 3 times x to get 3x and 3 times 5 to get 15. So if I'm going to undo this, I would take my expression of 3x plus 15 and I would divide each by that GCF of 3. The way I'm going to write it is what I divide by goes out in front of my parentheses, and what I have left will go inside. Well, 3 divided by 3 will give me 1, so I'll be left with just x, and 15 divided by 3 would leave me with a positive 5. And you can see I got right back to my starting expression. All right, so let's put this to practice, and we're going to factor these expressions using our GCF. So looking at number 1, if I have to, I can come out to the side and I can make my little table like I was doing on page 1, if I can't think of the greatest common factor off the top of my head. All right, so looking at these two terms, 8 and 6x squared, they don't share a variable in common, so I'm not going to pull a variable out. So I'm just looking at the numbers 8 and 6. What I like to do is I take the smaller factor, which is 6. I list all of its factors. So I have 1 times 6 and 2 times 3. And I'm going to start at the largest number and see, does 6 go into 8? No, so that can't be the GCF. Does 3 go into 8? No, so that can't be the GCF. Does 2 go into 8? Yes. There's my GCF. So I'm going to divide both terms by 2. What I divided by, remember, goes out in front of a set of parentheses. And what is left will go inside. So when I divide this, 8 divided by 2 gives me 4. And a positive 6x squared divided by 2, well, 6 divided by 2, think your laws of exponents. View this as a laws of exponents problem. 6 and 2 give me a positive 3, and the x squared just gets tacked on. So that would give me 2 parentheses 4 plus 3x squared. You have to have all of that for it to be an equivalent expression. Now you can do a quick check step. Your quick check step is just to distribute to double check that it equals your starting expression. Think 2 times 4 gives me 8, and 2 times 3x squared gives me 6x squared. See how this matches our starting expression? We know we did it correctly. All right, number 2. Start with our GCF. Well, smallest number of 2 only has 2 factors, 1 and 2. 2 can go into both, so that is my GCF. Remember, my GCF comes out in front of a set of parentheses. What's left will go inside. So 2 divided by 2 would leave me just an n, and negative 4 divided by 2 would leave me negative 2. So then I can do my distributive property to double check my answer. 2 times n gives me 2n. 2 times negative 2 gives me negative 4. That matches my starting problem. We did it correct. Number 3. All right, now these have a number in common and a variable in common. So again, I'm going to take the smallest number and I'm going to list its factors. 1 and 4 and 2 times 2. Then I check the largest number first. Can 4 go into 12? Yes. So that is part of my GCF. Now remember, as far as the variable, it's always the variable with the smallest exponent. So that means n is the GCF. So I'm going to divide by 4n. So that number is going to go in front of my parentheses, and I'm going to simplify. 4 divided by 4 would give me 1, so those go away. And think your laws of exponents. N squared over n, I have to subtract those exponents, and I would have 1n left. For the second term, 12 divided by 4 gives me 3, and think n divided by n would cancel out, so there would be no n's left in that second expression. When you get to this step, you should not have anything in common in what's left in the parentheses. If you still have something left in common inside the parentheses, that's a dead giveaway. You made a mistake somewhere and you haven't finished the problem. Again, we can do our double check. 4n times n gives me 4n squared, and 4n times 3 gives me 12n. Matches my starting problem. I did it correctly. Number 4. GCF of 3 and 9. If I list out my factors of 3, that's just 1 and 3. So 3 is my GCF. That's going to go in front of parentheses. 3 divided by 3 is 1, so that goes away. I'm left just r. And 9 divided by 3 gives me 3. Notice nothing left in common inside those parentheses, so that is my final answer. I can do a quick check. 3 times r is 3r, and 3 times 3 is 9. It matches my starting problem. I've done it correctly. Number 5, take the smaller factor. 3 only has 2 factors, 1 and 3. 3 can go into 12, so that's going to be my GCF. Now, here is something super important. Whatever the sign is of this first term has to be the sign of my GCF. That is always true. And if you look at all the previous examples I've done, all of them started with a positive term, which is why my GCF was always positive. All right, they do not have an A in common, so negative 3 is my GCF. Divide them both by negative 3. Well, negative 12 divided by negative 3 leaves me positive 4, and I have an A. And negative 3 divided by negative 3 is a positive 1. You have to be really careful and make sure that you actually put that positive 1, because if you don't, it's actually not equivalent. You would check that and notice if I didn't have that plus 1 there, I would just get a negative 12a, and that's all I would have. Well, that's not what I started with. I have to also have that 1 there so that when I multiply by negative 3, I get that negative 3 in the back. All right, number 6. Looking at my 2 numbers, 4 is my smallest number. It only has 3 factors, 1 and 4, and 2 times 2. Well, 4 can't go into 5, 2 can't go into 5, 1 can, but that doesn't help me. Dividing by 1 doesn't reduce anything. So then I look at my variables. My smallest exponent is my GCF. So that means my GCF for these two factors, or these two terms, is an R. That's going to go in front of my parentheses. If I divide by R, these R's will cancel out and I'm left with just 5 there. For the second term, remember that 4 is going to come over because it can't simplify with anything. But if I look at these R's, if I subtract, if I take 1 out, I'm left with 1 R in the numerator. Again, I can do a quick check. R times 5 gives me 5R, and R times 4R gives me 4R squared. That's what I started with. I'm good. All right, number 7, I'm going to start first by looking for the GCF. I'm going to take the smallest term, which is 21, and I'm going to list its factors. I have the factors of 1 times 21 and 3 times 7. Start with your largest value. Can 21 go into 49? The answer is no, so that goes away. Can 7 go into 49? Yes. So that is the number that they both share, and they do not have a variable in common, so I can't pull a variable out. So remember, that term will go out in front of parentheses, and then I'm going to divide. So 49 divided by 7 gives me 7, and I bring my m over, and 21 divided by 7 gives me my -3. I'm going to do my check step. 7 times 7m gives me 49m, and 7 times -3 gives me -21. It matches what I started with. I've done it correctly. All right, number 8, I actually have 3 terms. So whenever I have 3 terms, I can focus on, again, the smallest factor of all 3, which is 3. And I can list its factors. 3 only has 2 factors, 1 and 3. Start with your largest. Can 3 go into all 3 of these terms? The answer is yes. So that is going to be my GCF. Double check to make sure they don't have a variable in common. They don't, because the 9 has no variable at all. So remember, that's going to go in front of my parentheses, and I'm going to divide. 3 divided by 3 goes away, so I'm left with k squared. -6 divided by 3 gives me -2, and I tack on my k, and 9 divided by 3 gives me 3. Now let's do our check step. 3 times k squared gives me 3k squared. 3 times -2k gives me -6k, and 3 times 3 gives me 9. Matches my starting problem. I've done it correctly. Number 9. Look at all 3 terms, pick the smallest term, 4, and I'm going to list its factors. Again, it has factors of 1 and 4, and 2 times 2. Start with 4. Can 4 go into all 3? The answer is yes. So I'm going to divide them all by 4. Check for a variable. They don't all 3 have a variable, so I'm going to only divide by 4. That number goes out in front of parentheses. 4 divided by 4 would go away, and I'm left with k squared. 8 divided by 4 gives me 2, and I tack on my k, and 12 divided by 4 gives me 3. I can do my check step. 4 times k squared gives me 4k squared. 4 times 2k gives me 8k, and 4 times 3 gives me 12. That's my original problem. I've done it correctly. All right, number 10. Start first with my GCF. Now this one's a little bit more challenging because I have a lot happening. Notice I have R's with multiple exponents. Start first with your numbers. Remember that whatever this sign is has to be the sign of my GCF. I'm going to write it down here so I know it has to be negative. Now I'm going to look at the numbers first. 9, 27, 6. 6 is my smallest value, so I'm going to start there. I have factors of 1 and 6, and 2 and 3. Can 6 go into all 3 of those evenly? No. Doesn't go into 9 or 27. 3 does go into all 3, so that's going to be the number that I divide by. And then I also have to check for my variables. Remember, my variables, you can pull out the smallest exponent. So they all have a minimum of an r squared. So I'm going to tack that on as part of my GCF. Open my parentheses, and now I'm going to divide. -9 divided by -3 is +3. If I pull r squared out of r to the 8th, think your laws of exponents, I subtract and I'm left r to the 6th. 27 divided by -3 gives me -9. And if I subtract 6 minus 2, I'm left r to the 4th. 6 divided by -3 is -2. And if I subtract, those r's go completely away. Notice there's nothing left inside the parentheses that is in common, so I know I've pulled out the proper GCF. Again, I can do my distributive property to check. -3 times 3 is -9. R squared times r to the 6th gives me r to the 8th. -3 times -9 is +27. R squared times r to the 4th is r to the 6th. -3 times -2 gives me +6, and I tack on my r squared. It matches my original problem. I've done it correctly. All right, number 11. Remember, the first term is negative, so we know that has to be part of my GCF. Now I'm going to take my smaller term, 25, and I'm going to list its factors. I have 1 and 25 and 5 times 5. 25 does not go into both of those. 5 does. So that's going to be the value I divide by. Then I have to also check for my variables. M to the 4th and m squared. I picked the smaller of the two. So that's m squared, n squared, and n squared. They're the same, so I can pull the full thing out. And then they don't both have an O, so I can't divide by O. Drop that GCF down in front of my parentheses, and let's divide. -25 divided by -5 is +5. M to the 4th and m squared. I subtract that, and I'm left m squared. N squared and n squared, those would go away, and I'm left an O. For my second term, -35 divided by -5 is -7. M squared and m squared would cancel out, and n squared and n squared would cancel out. So now I'm going to move that parentheses over, and this is my answer. Now I'm ready to check. -5 times 5 is -25. M squared times m squared is m to the 4th. No other n squareds, that comes down. No other o's, that comes down. -5 times -7 gives me +35, and then my variables just come down. It matches my starting problem, so I know I've done it correctly. Number 12, I'm going to look first at my numbers, take my smallest term, 2, and I'm going to list its factors. I only have 1 and 2. Can 2 go into all 3 numbers? Yes. Now remember, I'm going to drop that negative down. I'm going to divide by -2. And then I need to check, do they all share a variable in common? No. So -2 is my only GCF. So then I'm going to divide. -4 divided by -2 is +2. Bring down my m squared. -2 divided by -2 is a +1. Remember, I don't need a coefficient of 1, so I'm just going to drop down n to the 5th. And 8 divided by -2 is -4. So there's my answer, and I'm ready to check. -2 times 2 gives me -4. Drop down m squared. -2 times, remember there's a 1 here, would give me -2. Drop down my n to the 5th. And -2 times -4 gives me +8. Matches my starting problem. I've done it correctly. All right, last 3. Number 13, start first with your values, your coefficients, 12, 4, and -20. Smallest is 4. It has factors of 1 and 4 and 2 and 2. Does 4 go into all 3 coefficients? Yes. So I'm going to divide all by 4. Look for common variables. They all share an a in common, so I pick the smallest exponent, and I can pull out an a cubed. They do not all share a b in common, so I can't pull that out. And they do not all share a c in common, so I can't pull that out either. So my GCF is 4a cubed, open my parentheses, and now I'm ready to divide. 12 divided by 4 gives me 3. When I pull out an a cubed, those will go away, and I can drop down b, c to the 4th. 4 divided by 4 gives me 1. If I pull out a cubed from a to the 5th, I'm left a squared, and I can drop down my c to the 5th. Negative 20 divided by 4 gives me negative 5. If I pull out a cubed, I'm left a cubed, and I can drop down my b. Now I can take that and I can do my check step. 4 times 3 is 12. Tack on my a cubed, b, c to the 4th. 4 times 1 would give me 4. A cubed times a squared gives me a to the 5th. Drop down my c to the 5th. 4 times negative 5 is negative 20. A cubed times a cubed gives me a to the 6th. Drop down my b. It matches my starting problem. I know I've done it correctly. Number 14. Now I have 4 terms. I'm still going to look to see if they all have something in common. Number-wise, my smallest term is a 3, which only has factors of 1 and 3. Can 3 go into all 4 coefficients? Yes. So I'm going to divide all 4 by 3. And then I'm going to look, do they all share a variable? They do. They all share a variable of x. And since that's the smallest exponent, that's what I'm going to divide by. So pull a 3x out in front. If I do 3 divided by 3, I get 1. And if I pull an x out of x to the 5th, I have x to the 4th. 18 divided by 3 is 6. If I pull an x out, I'm left x squared. 6 divided by 3 is 2. If I pull an x out, I'm left x. And 3 divided by 3 gives me a negative 1, and the x's would go away. Now I'm ready to do my check step. 3 times a 1 gives me 3. X times x to the 4th is x to the 5th. 3 times 6 gives me 18. X times x squared is x cubed. 3 times 2 is 6. X times x is x squared. And 3x times negative 1 just gives me negative 3x. Matches my original problem. Done it correctly. Last problem. Start first with our smallest coefficient, which is 4. We have factors of 1 and 4 and 2 and 2. Does 4 go into all 3 coefficients? Yes. So I'm going to divide by 4. Now remember, this is negative, so I have to use a negative 4. All because of the first coefficient. Then I'm going to look, do they all have a p in common? Yes. So I'm going to take the smallest exponent. Then I'm going to look, do they all have a q in common? Yes. So I'm going to take the smallest exponent. All right, so I'm going to put this out in front of my parentheses. And I'm ready to divide. Negative 4 divided by negative 4 is 1. P squared divided by p squared is 1. And if I pull a q out of q to the 4th, I'm left q cubed. Negative 12 divided by negative 4 is positive 3. If I pull p squared out, I'm left p to the 5th. And if I pull a q out, I'm left q. Negative 24 divided by negative 4 is positive 6. Pull a p squared out, I'm left p, and the q's would go away. So now I'm ready to do my check step. Negative 4 times 1 gives me negative 4. Drop down my p squared, and q times q cubed gives me q to the 4th. Negative 4 times 3 gives me negative 12. P squared times p to the 5th gives me p to the 7th. And q times q gives me q squared. Negative 4 times 6 gives me negative 24. P squared times P is P cubed. Drop down my Q. It matches my original problem. I've done it correct.